This section is 7.3 on sum and difference identities. So what we're doing in this section is taking trig identities of two different angles and adding or subtracting those angles together within the trig function to see what we get. So we end up with a set of formulas for cosine, sine, and tangent that we can use when we are given two different angles to add and subtract. If you would like to see how these are derived, you can look in your book and you can see where these angles come from. The first ones are for cosine. It says if alpha and beta are two different angles, so basically you just have two different angles, then cosine of alpha plus beta is cosine alpha times cosine beta minus sine alpha times sine beta. For cosine alpha minus beta, that is cosine alpha times cosine beta plus sine alpha times sine beta. You'll be given these formulas on tests and quizzes, but you should practice writing them out on your paper so you have them when you're doing your work. So here's an example. We want to show how this is true. So we want to say, giving our cosine addition formula, we could pick either one, we want to show how this is true. So I'm going to pick x equals pi thirds, which is really 60 degrees, and y equals pi 6, which is 30 degrees. And to figure this out, I'm going to use my trig, my special right triangle with 30 and 60, and I'm going to use my unit circle coordinates here. So what I want to say is I want to plug in x and y. So I'm going to have cosine of pi thirds plus pi sixths equals cosine of pi thirds times cosine of pi sixths, just plugging in for x and y, minus sine of pi thirds times sine of pi sixths. So I'm just going to simplify on the left-hand side here. I need a common denominator, add fractions. So I'm going to make this 2 pi over 6 plus pi over 6. That's just multiplying the first fraction by 2 over 2. Equals cosine of pi thirds. Cosine of pi thirds is cosine of 60. If I look from 60, my adjacent over my hypotenuse is 1/2. Cosine of pi 6 is cosine of 30. Adjacent over hypotenuse is 3/2. Minus sine of pi 6, which is sine of 30, is opposite over adjacent, root 3 over 2. And sine of pi 6, which is sine of 30, is opposite over adjacent, which is 1/2. Working again on my left-hand side, I have cosine of 3 pi over 6, just adding the fractions. On the right-hand side, I have root 3 over 2 minus root 3 over 2. When I simplify 3 pi over 6, that gives me cosine of pi halves. And on the left-hand side, or I'm sorry, the right-hand side, I end up with 0. I want to see, does cosine of pi halves equal 0? So I come up to my my unit circle. Pi halves is this first coordinate here. The point on that, the x value is 0, the y value is 1. Cosine, we remember, is x, so we have cosine of pi halves is 0, which equals 0. So we have shown that that angle addition formula works. So now we want to see how we use that in problems. So, for example, we want to find the exact value of cosine of 75. So cosine of 75 degrees isn't one of the angles we normally work with. So what we want to do is rewrite 75 as one of the really nice angles that we always use. So we're going to write 75 as a sum or a difference of one of our quadrantal angles or angles from special right triangles. So we want to rewrite 75 using 90, 180, 270, 360, 30, 60, or 45. So what I want to do is I want to say, well, cosine of 75 is really 30 plus 45. That's one way I could write it using addition. So I could say this is really cosine of 30 plus cosine of 45 degrees. Now I can use that to rewrite my addition formula. So I can say that equals cosine 30 times cosine 45 minus sine 30 times sine 45. Then what I want to do is again use my special right triangles. So in this case 45, I'm going to use, let's undo, doesn't let me. This is going to be 1 root 2 over 2, root 2 over 2, and for 30, I'm going to have, this is the 2, 1, root 3 side. So cosine 30 adjacent over hypotenuse is going to be root 3 over 2. Cosine of 45 adjacent over hypotenuse is going to be root 2 over 2. Minus sine of 30 is opposite over hypotenuse, 1/2. And sine of 45 is opposite over hypotenuse, root 2 over 2. I'm going to multiply this out. This is going to be root 6 over 2 minus root 2 over 2, which when I combine like terms, I get, or like denominators, I get root 6 minus root 2 over 2. I cannot simplify that further, so that is the exact value of cosine 45 degrees. So we have the same idea for sine. These are your sine addition and subtraction formulas for two angles. Sine alpha plus beta equals sine alpha times cosine beta plus cosine alpha times sine beta. And sine alpha minus beta equals sine alpha times cosine beta minus cosine alpha sine beta. So here's an example of how we might use either the sine or the cosine angle addition or subtraction formulas. So we have find the exact value of sine x plus y if x is between 0 and pi halves and y is between 0 and pi halves. Sine x is 4 over 5 and sine y is 5 over 13. So in order to use our sine addition, we also need to know cosine x and cosine y. We have sine x, we have sine y, we need cosine x, and we need cosine y. This information here, x is between 0 and pi halves, this is telling you this is in quadrant 1 where everything is positive. Y is also in quadrant 1 where everything is positive. So when I find cosine and x and y, those are going to be positive. If those were in different quadrants where cosine was negative, your values would be negative. So given sine, we can find those in two ways. We learned in the first chapter to find those using right triangles and the Pythagorean theorem, or we learned in this last section to use them using our Pythagorean identities. So I know that sine squared x plus cosine squared x equals 1. I know sine is 4 over 5. 4 over 5 squared is 16 over 25 plus cosine squared x equals 1. I'm going to subtract 16 over 25 to the other side. That's cosine squared x equals 25 over 25 minus 16 over 25. That's cosine squared x equals 9 over 25. And when I take the square root, I have cosine x equals 3/5. And I know it's positive because I'm in the first quadrant. I want to do the same thing to now find cosine y. So all I'm going to do is say sine squared y plus cosine squared y equals 1. Sine y is 5/3. 5/3 squared is 25 over 169 plus cosine squared y equals 1. I'm going to take the fraction to the other side. Cosine squared y equals 169 over 169, that's just 1, minus 25 over 169. Cosine squared y equals 144 over 169. Square root both sides. Cosine y equals 12 over 13. Again, it's in quadrant 1, so it is positive. So now I have sine x, sine y, cosine x, cosine y, and I can use my sine addition. Sine addition says sine x plus y equals sine x times cosine y plus cosine x sine y. So we were given sine x equals 4 over 5. We found cosine y was 12 over 13. We've found cosine x was 3 over 5. And sine y we were given was 5 over 13. So over here we have 48 over 65 plus 15 over 65. Those have like denominators, so I can add them up. And I get, I get sine x plus y equals 63 over 65. And that would be your final answer for that. Finally, we have the same idea for tangent. We have tangent of two angles, alpha plus beta, is tangent alpha plus tangent beta over 1 minus tangent alpha tangent beta, or tangent alpha minus beta equals tangent alpha minus tangent beta over 1 plus tangent alpha tangent beta. Again, these formulas can be used in the same way in any of the examples that we've used. So any of the examples we've done, you can use cosine, sine, or tangent angle addition or subtraction formulas. The last thing we want to look at is verifying a trig identity. So I want to verify that secant pi plus alpha plus a equals negative secant a using my angle addition formulas. So how this is going to look, I have secant pi plus alpha equals negative secant, sorry, not alpha, a. I want to think about reciprocal identities. I want to think about addition and subtraction formulas. So secant is 1 over cosine. So I'm going to change this to 1 over cosine pi plus a. This helps me because I don't have addition formula for secant, but I do have one for cosine. So if I rewrite that as a reciprocal, I'm going to be able to work with it a little better. So on the bottom here, I have cosine pi plus alpha. That is an angle addition formula. I have two angles, pi and alpha. I'm adding them together within the function of cosine. So I'm just going to replace this with the formula for cosine, which says cosine pi times cosine a minus sine pi times sine a is going to equal negative secant a. So what I want to do now is, again, look at my handy dandy unit circle. I am dealing with angles at pi. So pi is here. At this point, I'm at the point negative 1, 0. Negative 1 is my x value, 0 is my y value, x is cosine, y is sine. So anytime I have an angle involving pi, I can just plug in these values. So cosine of pi, my x value at pi, is negative 1. I'm just going to leave cosine a. My sine at pi is 0. I'm going to leave sine a. Oops, this is all over 1, under 1, minus secant a. This 0 goes away, and I end up with 1 over negative cosine a, which equals negative secant a. Since 1 is a reciprocal, or since cosine is a reciprocal of sine, this side equals negative secant a, which equals negative secant a. And that is all. So we will do more examples in class. Rewind, re-listen, write it down. Make sure you are prepared and ready to go.